OK, so the next thing you kind of want to do is, from a high level, sort of think, how is my app going to interface with Firebase? So the super, super high level is that we really want to think of Firebase as kind of a black box. And it's this black box that we're going to pass a local selfie file into, of the file that we took on our Android app. And then we're going to get back a URL of that process redacted selfie. And all of this communication will be done through the Firebase SDKs. So let's take a look at what that code looks like. So the code for uploading a file to cloud storage is this. I get a file. I determine the location in cloud storage that I'm going to upload it to, and then I start the upload. This part here is what I need to communicate with Eric about. So basically, in this example, I'm putting it in a storage bucket with the path quarantined images, and I'm using some sort of unique ID. This basically is a lot like a file path. When I'm doing the upload, I need to do one more thing, which is create a listener. Many of the Firebase APIs operate with a sort of push mechanism. So you set up listeners, and then Firebase will trigger your application code with the data that you're interested in it when it changes. In this case, I want to put the listener on a specific location in the Cloud Firestore database, which I, again, agreed upon with Eric. And this is where his Cloud Function is going to put the redacted selfies URL. OK, so what does that code look like? So here's a snippet, again. I get the path from my Firestore database. And again, this is the path that I've agreed upon with Eric. Then I attach the listener to that location. Every time something happens at that location for this selfie that I'm listening for, that listener is going to get called in my application code. And I'm either going to get a snapshot of what the data in my Firestore database looks like, or I'm going to get an exception. And I've agreed with Eric that he's going to put it at this URI path. And so that's where I'm grabbing the URL from the redacted image. Since I add the listener, I also need to make sure to clean it up. So the full flow when we're doing that sort of redaction looks like this. The Android app is going to upload a local file using cloud storage, and it's going to attach a listener. In the black box of Firebase, Eric's function code is going to run, and it's going to redact the selfie. Once that selfie is redacted, it's going to put the URL for that redacted selfie into Firestore. That's going to trigger the listener that I set up. And at that point, my application code will get triggered, and I'll be able to either just see whether it resulted in an error or it resulted in a redacted selfie for me to show. OK, so that all sounds great. But we haven't talked about where these two sort of floating snippets of code actually go in our Android app. So one big theme for Android development over the past few years is a greater focus on architecture. Think about all of the architecture component libraries that have come out from Android Jetpack. Think about the guidance around architecture that we have in our documentation. We also have a really great code lab called Room with a View. And shameless self-plug, we just put out a new Udacity course called Developing Android Apps with Kotlin that also is heavily invested in this architecture. So when you're talking about how do I get Firebase and Android to work together, it's really important to think about your application architecture and discuss where Firebase fits in. So I've copied here kind of what the architecture diagram looks like that we go over in the Guide to App Architecture. Now, if you look down at the data layer, we have this sort of common pattern where we have a network data source, assuming that we're talking to the internet, which we are for our selfie app. And we have a local database so that our app continues working offline. Both of these go ahead and produce live data, which are then combined in the repository and eventually make their way back up to the UI. So the thing about the Firebase SDKs is that they manage your network, basically the operations that you would have been doing in your network data source. The SDKs also manage a local persistence layer that acts as an offline cache. So it's potentially possible, if you move everything over to Firebase, that you could replace those two data sources with a Firebase data source and have that in place of your network and local database data sources. The Firebase data source would also produce a live data, which would then go up to the repo and eventually make it up back to the UI. OK, so let's zoom into that Firebase data source and talk about kind of how to implement it. It needs to do two things. It needs to upload the file using, and we're going to use cloud storage as discussed. And then it also needs to make a Firebase listener that gets the redacted selfie URL. Let's go ahead and dive into the upload first. So Cloud storage works out of the box with what I'm calling tunnel mode. And this is essentially the idea that if I have my app and I walk into a tunnel and I lose connectivity for a little bit of time, that Firebase will handle that for you. If the upload has to stop, and then for a tiny bit of time, it'll gracefully continue the upload for you. Things get a little bit more complicated when we go into what I'm going to call airplane mode, which is I get on an airplane, or for some other reason, I'm offline for an extended period of time. So while I'm offline, I might close my app, my phone might run out of battery and restart. And if those things happen, Firebase is not going to automatically restart the upload for you. So that becomes something that you as a developer have to manage. Luckily, Android Jetpack has an API that makes this really easy. And any guesses what it's called? Workmanager. All right, so Workmanager is a library for managing deferred and guaranteed background work. And basically what that means is it's for work that absolutely needs to run at some point, but you're not you don't care a huge amount if it runs absolutely immediately or at a specific point in time. The nifty thing about Workmanager is that it'll manage restarting and retrying uploads even if your app shuts down. There are also some cases where if you fail enough retries, Firebase will kind of give up uploading that photo, and Workmanager can also help you handle those as well. OK, so starting a Workmanager job is pretty quick. You make an object known as a work request, and then you tell Workmanager to enqueue it. But Workmanager has additional features that we want to use here. It also supports, of course, putting some input data into your job, and it also has constraints for jobs. So in this case, when I get a local selfie and I take a picture, I have the URI for that selfie, and I want to pass it into Workmanager. And also, I want to add a constraint that we can see right here, which is that I only really want to be doing this if I have a network connection. If I don't have enough network connection, no use in trying to upload it. Now, you might have noticed that that snippet that I showed you before with the actual upload code isn't on screen right now, and that's because it's defined in this upload worker class. So let's dive in and see what that might look like. OK, so here you can see I put that snippet that we were looking at before. But there is one problem with this. And it's that we're using the default worker class. So the default worker expects that you do all of your work synchronously. And at the end of that, when you're done doing all of your work, that you know whether you have failed, succeeded, or you need to retry. Now, we can check for this. So like most Firebase APIs, it's asynchronous, and it involves listeners. So we can get a task back from our upload, that upload operation, and we can add a listener to it to see if we succeeded. But unfortunately, even though we add that listener, immediately the next line of code is going to be executed, and we still don't know whether that task has actually succeeded. OK, so one solution that I'm going to come back to a few times in this talk is to incorporate Kotlin coroutines. So who here has used coroutines? OK, fewer than has used Firebase. So introducing coroutines is probably a talk in and of itself. So I'm going to try to just get to the simple ideas behind coroutines that we're going to leverage. So the simplest idea behind coroutines is that they simplify asynchronous code by replacing callbacks. And there's this special keyword called suspend that you can stick in front of a function to make it a suspend function. And when you make a function a suspend function, you can run long-running code in there without worrying about blocking the main thread. And this is an idea that we call main safe code. So Workmanager supports coroutines by having a flavor of worker known as coroutine worker, which does its work in a suspend function. And there's also a library that integrates Google Play Service tasks with coroutines. Tasks are what the Cloud Storage API returns when you try to do an upload. So if we stick these two together, we can write Firebase callback code that looks and acts like synchronous code. So let's see that. OK, so here's our old worker class that wasn't working out for us. I'm going to transform that into a coroutine worker. And to do that, I just needed to do two things. I'm now extending coroutine worker, and my do work function is now a suspend function. And I'm going to get rid of that code that I have before. The basic flow that I have right now is we're going to try to do that upload. And we're going to use coroutines to safely wait until that upload is finished, because, again, the suspend function is made safe. If it fails and it throws an exception, we'll return a fail or retry result. And if it gets to the end successfully, then we'll return a success. All right, so this is basically almost the same code that I had before. The really special little bit here is this upload task.await. The await function is a coroutine-specific function, and it basically says to wait for the result of a deferred value. So this says wait until that upload task is finished. And this is the functionality that the kotlinx coroutines play services library provides. It lets you wait for a task to finish before continuing to the next step of code. Await needs to execute within the bounds of a suspend function, and do work is now a suspend function, so we can do that. Do work is also using the default dispatcher by default. Now, if await finishes without an issue, it's going to go to the next line of code and return a success. But if during the upload it gets some sort of storage exception, then the catch block will fire, and either I can look at what storage exception I got and then decide within that block whether I'm going to retry or whether I've just failed completely and Workmanager should stop trying to do the upload. OK, so now I've dealt with the uploading a file part of this. And I've used cloud storage as well as Workmanager and coroutines. Let's go ahead and take a look at that listener code. Ultimately, what we want to do is produce some sort of live data to communicate back to the UI. We want to take the information that we get out of Firebase, pipe it through live data, and then use that to update our views. There's going to be a number of things that we need to think about to get this to work. The first is how we're going to convert the listener callback code into live data. OK, so here's my first attempt, and I should probably have a big red X on it because it's not my final attempt. So what I'm doing right here is I'm making a function that returns to me some live data, and my goal is it to be this live data that is spewing out, kind of what Firebase is giving me. And it's just going to output document snapshots, and I'm not going to worry about error handling yet. So I register my listener as before, and when I get a valid snapshot, I output that on my live data. And then at the end of this function, I return that live data that I've just created. One thing that you might notice is I'm not handling actually removing the listener, which is it's a code smell. OK, so I want to make sure that when I'm listening to Firebase and I'm getting updates out of Firebase, that I actually have UI components or parts of my app on screen that need those updates. So if I have some UI on screen that needs those updates, I want my listener to be registered and added. But if my app is off screen, I don't need that listener running. And if it is running, it's wasting my user's data plan. Luckily, the lifecycle libraries from Android Jetpack give us the concept of lifecycle awareness. This is the idea that you can automatically adjust the behavior of a component based on a lifecycle owner. And examples of lifecycle owners are things like activities and fragments. So live data is lifecycle aware. And essentially what that means is it knows when it has activities and fragments observing it, whether those activities and fragments are on screen or off screen. So when it goes from having no observers on screen to having an observer on screen, it triggers this callback on active. And when it goes from having observers on screen to having no observers on screen, it calls on inactive. So we think, maybe we can use this to get our listener registration code working. So if I have a document snapshot live data and some fragment observers come on screen, onActive will be called, and this might be a really good time to attach that Firebase listener. Now let's say later that those fragment observers start going off screen and the last one goes off screen. At that point, onInactive is going to get called, and that might be a really great time to remove the Firebase listener. Unfortunately, there's one major issue, which is a big thorn in my side, and that's that some funky stuff happens when we go through a configuration change. So examples of a configuration change are things like rotating your phone. So if you set the listeners up in this way, you're going to have a sort of subtle bug. So when you try to rotate the device, when a configuration change happens, your UI is going to get destroyed. So both of these fragments are going to get destroyed, thus triggering on inactive. But immediately, the UI is going to get rebuilt. New versions of those fragments are going to get reattached. And then immediately, onActive is called. So I've now created this situation that whenever I rotate a phone, I'm suddenly immediately detaching and then attaching a listener. And if I set up a bunch of live data in this way, or if I sit there rotating my device, this is going to be a big performance pain, and I'm going to be making a lot of extra network calls. So what I really want is the ability to kind of wait a little bit and to only remove the listener when we're sure that we're actually done. This will help us differentiate between whether we went inactive because the listeners, the fragments and UI components actually went away forever, or whether we're in a sort of configuration change state. Now, there's two ways that you can deal with this that I'll go over fairly quickly. So the first one is to use the new live data builder. If you went to the architecture components and coroutines talk yesterday, they covered this. So this builder creates live data that has an associated coroutine scope. This coroutine is canceled when the live data becomes inactive, but it includes this wait a little bit behavior before canceling the coroutine. The coroutine is rerun if it was canceled before it got all the way to before it finished. This gives us a similar mechanism to what we were looking for with the kind of on-active, on-inactive code. OK, so let's take a look at how we might implement this. So here's us getting live data using the live data builder. Notice that you pass a time out into that. So that's the amount of time that it will wait before canceling your coroutine. All right. So this coroutine code, I have to admit, is fairly complex. So take a photo or go back online after the end of this talk. But the main idea here is that you can put your listener registration code in here. The listener removal code removes the listener when the coroutine finishes or is canceled. Remember that the coroutine is canceled when the live data becomes truly inactive. Note that we don't want this coroutine to actually ever finish organically. We only want it to be canceled. Therefore, we have to make sure that it sort of suspends forever so that it could keep emitting the results from that listener, and that it will only actually stop when it becomes inactive. OK, so another option, if you're not using Kotlin or coroutines, is presented in Dov Stevens' excellent talk, Firebase and Jetpack Fit Like a Glove. He has a full code example online, which sets up something called a lingering live data, which is essentially a live data that waits a little bit before determining that it actually has become inactive. OK, so at this point, we've talked a little bit about the conversion. We've talked a little bit about handling listener registration with lifecycle awareness. Now I want to talk about handling having an error state, a loading state, and a success state. So right now, we're emitting document snapshots from this live data back to the UI, which is not great. One of the reasons it's not great is because we only essentially know if it succeeded, and it doesn't have an error state or a loading state. Also, document snapshots are a Firebase-specific data type. And we really want to make it so that the UI code has no concept that we're using Firebase in the data layer, and we want to not be communicating that back up. So it'd be really great if we could have that live data emitting something that was not Firebase-specific. OK, so for this, I'm going to use something called Kotlin sealed classes. So Kotlin sealed classes, you can think of them as a little bit like supercharged enums. They act like enums, but they could contain a little bit of state as well. So I'm going to make two different types of sealed classes. One is for the data that I get back from Firestore, which I'm calling Firebase doc result. Notice this pattern here where I define a sealed class, and then I make a bunch of subclasses of that sealed class. And I can differentiate between whether I got back an exception or I got back a snapshot. I'm going to make another sealed class for selfie status. And this is what actually goes back to the UI. These are the different states that the app could be in. Either it is actively loading up, waiting for Firebase to give it back a selfie. Either it's errored out, or we have our final selfie. And this is ultimately what I want to expose back to the UI. OK, so now here's what our flow looks like. I get the snapshots and exceptions from Firebase. I turn that into a live data, which is a Firebase doc result live data. I'm going to use live data's map transformation to turn that live data from the Firebase-specific thing to the more generic selfie status thing. And that's what goes out to my image view. And the code for that flow that I just showed you is this. So again, I'm using the live data builder class to create a live data. This is the selfie status live data that's going to be exposed to the UI. The first thing that I want to do is emit a loading state. Emit is saying, here's the data that actually goes out on my selfie status live data. So the first thing I'm in is a loading state. Then I want to specify which document I'm interested in listening to. OK, and then I use this get Firestore document live data, and that's implemented using one of the two methods that I went over, either lingering live data or using the live data builder. But essentially, this is going to give me back a live data that is inactive, that removes and adds its listeners appropriately. And then finally, I'm going to map that live data from the Firebase-specific results to the generic selfie status results. And that is what this function makes for me. OK, so the last thing that I want to handle is what happens when I take multiple pictures. I need to make sure that this code still works. For that, we're going to be using another live data transformation known as switch map. So switch map allows your UI observers to observe a single live data while swapping out a backing live data. And if you're looking at this for the first time, it's easy to confuse switch map and map. But the difference is largely in that switch map involves this backing live data. So let's look at a scenario. So without switch map, this is no switch map situation. This is the situation that I'm in. I have a live data with a local URI of some selfie picture that I just took. And I'm going to call that picture A. And I have this selfie status live data, which is outputting the selfie state for picture A. Now let's say I take another picture, picture B. So I could use the code that I just wrote to generate another selfie status live data for picture B, and I could listen to it. But I have the issue where I'm still listening to selfie status picture A live data, and now I have to deal with stopping observing things in my fragment, and that becomes confusing. And as soon as I start hitting problems like that, that should be a code smell that you should be using switch map. So if instead I use switch map, I'm going to set up the logic this way. I'm going to have a live data, which is emitting the URI of the current picture that I've taken. So it's emitting live data A. And whenever a new URI is emitted, that's going to cause another live data to be created, which is a selfie status live data. And then I'm going to have the fragment not observe that live data directly. It's going to observe another live data, which is backed by the picture A live data. Then, if at some point in the future I take another picture, the URI live data is going to change. That'll auto-generate another live data for me, and all of that swapping behavior for the observers will be handled for me. I don't have to change what my fragment is observing because it's observing that live data that never changed. OK, so final flow. I have a live data for the local picture URI. When I take a photo that changes the local picture URI, I use switch map, which is going to swap out for me a new live data at the right selfie location. So Firebase feeds into that, and I'm using one of those two methods that I discussed. This is ultimately what I want is to get this selfie status live data, which is what's going to go out to my view. OK, so here's the code, and it's essentially the same block of code that I showed you before. I've just added the switch map in here. Whenever the local picture URI changes, a new live data will be created and swapped in as the backing live data using the same builder logic. OK, so zooming way out, I've implemented both upload and listening for the selfies. For upload, I use cloud storage and a coroutine worker. And for the for listening for new selfies, I'm using Firestore, switch maps, the live data builder, and sealed classes. And zooming out again, at the start of this section, I mentioned that the Firebase SDK was kind of like a black box to us that has some function code in it. So now we're going to open up that black box. Let me welcome back Eric. Thank you.
Thanks, Lyla. So the most important part of the functions code is listening for that image upload to cloud storage. You can access that file and different data about that file, as you see here. Here are some of the different data types we'll be checking for in our app. Phone number, date of birth, name, location, email address, ID and credit card numbers, etc. Next, we prepare the info types and image for our API request. Now we construct the API request. And then we execute the DLP API request. From it, we will receive a redacted image and all the data matches with their respective match likelihood. We now have a redacted image. We can upload the image to cloud storage. And with that uploaded redacted image, we need to update Firestore with that URI to the image so our app can update the view. And that's it. Now let's see how this all comes together, shall we? Here's a live demo.
All right. Cool. All right, so I got my redacted selfie on screen, and we can also see what Firebase looks like right now. So let's take a selfie. All right, so I have this totally legitimate license right now. OK, hopefully that's clear enough for the Reaction API to go. Let's see. All right, so it's uploading to cloud storage. All right, and the redaction has happened. So Eric's going to now show kind of the two versions of those image. We have the unredacted version there. And then his cloud function triggered, created the redacted version. And you can see there on the other side that in our Firestore database, that's the URL that it gave back to me, and I could then display it in my app.
Great. If we can go back to the slides.